As simple as this question is, a lot of students actually fail this question in the JAMB exam. Let's take a look at the question. It says a man walks 8 kilometers north and then 5 kilometers in a direction 60 degrees east of north. Find the distance from his starting point. Now, for a question like this, there are two ways you can actually do this, but let's see the first one. Say walks 8 kilometers north. North is the up part. Say walks 8 kilometers north. So if here is 8 kilometers, and then 5 kilometers in a direction 60 degrees east of north. 60 degrees of north, here is north. This part is east. So east of north means the angle is between east and north. East of north means the angle is closer to the northern part. So here becomes 60, that's closer to the north. And then we have 5 kilometers. Here's 8 kilometers. So now that's the distance from the starting point. To find the distance from the starting point. So that's the diagram we used to calculate the distance of the man from his starting point. Now the first thing is to get this inner angle. From here to here is 90. This part is going to be 30 because the entire angle here is 180 degrees. And since here is already 60 and from here to here is 90, 90 minus 60 will give us 30. So we have 30 plus 90. So here will give us 120 degrees. So now for this one, we can apply the cosine rule. If you apply the cosine rule, then I'll get this square equals 5 square plus 8 square minus 2 times 5 times 8 cos 120 degrees. So we'll get this square equal to 25 plus 64 minus 80 cos 120 cos 120 is minus 0.15. That's minus 0.5. So minus minus will give us plus. So we have this square. This one will give us 80 minus minus is plus. 80 times 0.5 will give us 40. So when you add up this one, you get this square equal to 120 and they will now be the square root of 129. And when you find the square root of 129, that will give us 11.36 11.36 kilometers. And that is option A. Now this one is okay, but supposing you were asked to get the direction. You were asked to get the direction of the man from the starting point. There's another approach we'll use to get this distance, and then we can as well calculate the actual direction in terms of north, south, east, or west. Let's see that other approach. So we said the man walks 8 kilometers north. This is the north. So we have 8 kilometers. Then 5 kilometers, 60 degrees east of north. There will be 60, because here is north and here is east. And then we have 5 kilometers here. So now, if you are using this XY plane, this up part is positive. Here is also positive. This down is negative. There is negative here. and then this up part here is what? Positive. So now, we resolve now. We use what? The resolution of what? Vectors. Let's resolve to the horizontal components. For the horizontal components, fx, we have 5 sine what? 60. 5 sine 60. Then for the vertical components, fy, 8 kilometers already along the vertical and is on the positive axis, so I have 8 plus, then we have 5 cos 60. Now, in our previous lecture from parts 1 to 3, I've always told you that if you move to the side where the angle is, you have what? 60, cos. So now that I'm moving the 5 kilometers to this direction where the 60 is, that's how we have what? Cosine. And then if we move to the side where the angle is not placed, we use what? Sine. So now if you've not watched the parts 1 to 3 of this mastering vector calculations, you can take a look at that after this what? Class. There are a lot of things that are going to learn from there. So this one will give us 0.866. So here we'll get 8 plus 5 times 0.5. So 0.866 times 5. That will give us 4.33. So Fy will have 8 plus 2.5, and that will give us 10.5. So from there, the next thing is to get what? The resultant, which is now the distance of the man from the starting point, and that will be Fs squared plus what? Fy what? Square roots. Okay, so that will be Fx is 4.33. Then Fy is 10.5. 10.5 square. So that will get R equal to, we have 4.33 square. That will give 18.7489. Then we have 10.5 square. That will give 110.25. So add up that now. We add up. So I'll get R equal to, we have 110.25 plus 18.7489 so that'll give 128.9989. And then when you find the square roots, you should get the same thing as what we got previously. That's 11.316. Okay, that's what we got what previously, 11.36. Now you see that the answers are the same. So now the reason I have to do this is so I can get what the actual what direction. Now take a look at this. You have the value of fx here, it's positive. The value of fy is here is also what? Positive. So since we have fx and fy being positive, then for the direction now, for the direction, we have tan theta equal to fy over what? Fx. Fy is 10.5. Fx is 4.33. So I'll get tan theta. We divide that now. We have 10.5 divided by 4.3 or 3. So we get 2.4249. So that theta will now be the tan inverse of 2.4249 and that will give 67.6 degrees. 67.6 degrees. So the next thing we have to do is to write this in terms of north, south, east, west. Now Fy is positive and Fx is what? Positive. Both of them are positive. Since both of them are positive now, I'll have this one. There's positive Fx. And here we have positive what? F what? Y. So that's your resultant here. And that's your theta. Here is north, here is south, here is east, and here is what? West. So now the angle theta is closer to what the eastern what part here. So what I will get is the resultant. Can write the answer now as R equal to 11.36. 11.36 kilometers. Then we have east 67.6 degrees north. That's the first way we can write this. We can also write that as R equal to 11.36 kilometers, then 67.6 degrees north of east. So that's the second way you can write that. But there's still another way you can write that. There's another way you can write that. So that we have R equal to 11.36 kilometers. We'll get this value of alpha first. So we'll get 90 minus 67.6. So that will give us 22.4 degrees. So we'll take the measurement with respect to what? Alpha now. If we do that, we'll get 11.36 kilometers. Then since alpha is closer to the north, I'll have north 22.4 degrees east, and then we can also write that as R equal to 11.36 kilometers, then 22.4 degrees east of north. Okay, we did a lot of examples on this one in the part 2 and part 3 of this word series. Okay, so these are the different ways you can write the answers, and all the answers are what? Equivalent. Okay. If you have any question on this, don't forget to send it to me in the comment word section. Let's go over to example 2. It says the magnitude of the resultant of two mutually perpendicular forces of two mutually perpendicular forces, F1 and F2, is 13 newtons. If the magnitude of F1 is 5 newtons, what is the magnitude of F2? What is the magnitude of what F2? Now, for this type of question, if we want to get the magnitude of what F2, okay, let me write the options here. We have option A, 2.6 newtons. Option B, 8.0 newtons. Now we have option C, 12 newtons. Then option D, 18 newtons. So now you're told that they are mutually perpendicular with forces. So, the resultant, that's the resultant here. And that is what 13 watt newtons. The magnitude of F1 is what 5. So we are looking for the magnitude of what F2. So we have something like that. So now we get R square, which is the resultant now, 13 square, equals 5 square plus F2 was square. Because this part here is the same thing as 5 watt newtons. So make use of the Pythagoras theorem, because the forces are already what perpendicular. So we get 13 square, 169, and we have 25 plus what F2 was square. Transfer 25 across the equality. Since it's plus 25, if it crosses the equality sign, it becomes what? Minus. You subtract that to get 144 equals F2 square. And to get the value of F2, you take the square root of 144. And the square root of 144, that will give us what? 12 watt newtons. That is the value of F2. And that is option what? C. These things are not actually difficult. Okay? Just understand the basic principles of resolving what vectors, which you actually dealt with in the part 2 and part 3 of this word series. So if you are coming across our videos for the first time, try and look at part 1 to word 3 of this series. Let's look at the third word example. Example 3. It says a boat travels due what? East. A boat travels due east at a speed of 40 meters per second across a river flowing due south. At 30 meters per second. What is the resultant What is the resultant speed of the boat? What is the resultant speed of the boat? Now the options we have, A, we have 1.3 meters per second. And option B, 10 meters per second. And option C, 50 meters per second. And option D, 70 meters per second. Now you can pause the video at this point and try to see if you can solve this entirely on your own before checking the solution. It will help you better in learning what we are doing in vector with calculations. The boat travels due east at a speed of 40 meters per second across the river flowing due south. The river is flowing this way, 30. The boat is traveling due east at 40. So now what is the resultant speed of the boat? Resultant is going to be that way. And here is going to be the value theta if you ask to calculate that. But in this case, we don't need that. So here is also 30. Now the resultant r square, that would be 30 square plus 40 square, similar to the previous example. So r would be 900 plus 1600. So we have r as 2500. That's r square. So r becomes square root of 2500. And that will give us 50 meter. That will give 50 meter per second. And that is option C. It is not something difficult. You can actually handle these questions on your own. Now let's take a look at the next example. We're going to be looking at some very interesting questions in this series, which we didn't do in part 1, 2, or 3. So ensure you watch the video to the end. The next question says a ball is moving at 18 meters per second. Meters per second. In a direction inclined at 60 degrees to the horizontal. Stop. What is the horizontal component What is the horizontal component of its velocity? Okay. So the ball is moving at 18 meters per second in a direction inclined at 60 degrees toward the horizontal. So this is the horizontal. The ball is moving at 18 meters per second 18 meters per second in a direction inclined at 60 degrees to the horizontal. 60 degrees to the horizontal. What is the horizontal component of its velocity? Now, what that question is simply saying is that you should resolve to get what the horizontal component, f x. Resolve to get what fx. So if I resolve, I move this one to the direction where the angle is, fx direction, fx, which is the horizontal component. That will be 18. The side I'm moving to is where the angle is. We are moving to the horizontal this way. So to move to the side where the angle is placed, we have what cosine. So that will be 18 cos 60. And cos 60 is 0.5. So this one will give us 9 meters per second. That is the value of f Like I said, resolution of vectors is not something difficult. Once you have the angle, if you move the force or the displacement to the side where the angle is placed, you use cosine. If you move it to the other side where the angle is not placed, you use sine. That is just the simple rule you need to understand to solve every question that has to do with resolution of vectors. Let's take a look at the next example. Says the resultant, okay, let's leave that one, okay. So the resultant of two forces acting as an object, let's just take it. So the resultant of two forces, this is actually not a calculation question though, acting on an object. Acting on an object is maximum if the angle between them is okay, this is not a calculation question. I actually wanted to skip that, but let's just look at it. The resultant of two forces acting on an object is maximum if the angle between them is, let's say, for example, this is the object. You have two forces now. Now, if one of them acts in this direction, let's say they have different magnitudes. Let's say here's 5 Newton and here's 8 Newton. Here, we can really get the resultant here now. That will be 8 minus 5, right? That will give us the resultant in this case. 8 minus 5. That will be 3 Newton, and the object will move in this direction, right? Now we're looking for the point where the resultant is maximum. Now, if they are acting in opposite direction, you cannot get the maximum at that point. Here, the angle between them at this point is this. That's 180 degrees. 180 degrees. But if for you to have a maximum resultant, that's where the force will be greatest, is when the two forces, let's say this one like this, or the important thing is that both of them are acting in the same direction. Is yes 8, yes 5, and yes 5, yes. It doesn't matter the direction you draw this time around. Now this time the angle between them is 0 degrees. Okay, and the resultant here will be 8 plus 5. This one will give us 13 newtons, or in this case also 13 newtons, which is greater than this. So the resultant of two forces acting on an object is maximum if the angle between them is 0 degrees. If the angle between them is 0 degrees, that's where you get the maximum. Okay, let's look at the next question. Says two forces, each of 10 Newton. Two forces, each of 10 newtons, act on a body. Act on a body. One towards the north, one towards the north, and the other towards the east. And the other towards the east. And the other towards what the east. What is the magnitude what is the magnitude and direction of the resultant force? Now, if we want to get the magnitude and direction of the resultant force, the first thing I will do is to try to draw the diagram. I need to draw the diagram. Say the two forces act on the body, one towards what the north, 10 newtons, and the other towards what the east. East is this way, 10 newton as well. What is the magnitude and direction of what the resultant? Since we're talking about magnitude and direction, here's north, here's what east. One towards the north and the other towards what the east. So north, what east. So I have something like this. So now the resultant, r square, that will be 10 square plus 10 square. So you get r square. We get 100 plus 100. R square will be what? 200. R becomes the square root of what? 200. That will give us 14.14. 14.14 newtons. So now both of them are positive. Now, since both forces are positive, then tan theta, that will be F1 about F1 x. So I'll get tan theta becomes Fy, which is 10 over our 10. Tan theta will be equal to 1. And theta will be tan inverse of 1, and that will give us what? 45 degrees. That will give us 45 degrees. So now what we'll get becomes, since it's 45, you can just put the answer as R equal to 14.14 newtons, the north 45 degree east. I can read it as R equal to 14.14 45 degree east of north. You can leave the answer in that form. And that is also what correct. Both of them are correct. So now let's see the next example. Now, learning something from this lecture, ensure you hit the subscribe button to subscribe to our channel. Let's take a look at the next question. It says, an aircraft attempts to fly due north at 100 kilometers per hour. First up, the wind blows against it. The wind blows against it from east to west. From east to west at 60 kilometers per hour. First up, what is its resultant velocity? Okay, the options we have, option A, we have 117 kilometers per hour. North, 31 degrees east. Then option B, 127 kilometers per hour. North, 31 degrees east. And option C, we have 117 kilometers per hour. North 31 degrees west. North 31 degrees west. Then option D, we have 127 kilometers per hour. North 31 degrees west. North 31 degrees west. Now, let's look at this question. From here, you understand the need to actually know how to get the actual direction. Because if you don't know how to get that, this question will be difficult for you to solve. Let's say an aircraft attempts to fly due north. So that's north 100 kilometers per hour. The wind blows against it from east to west. That's from this way. It is blowing from this way. It's blowing from this part here. That's the east. It's blowing towards the west. So I have this one. From east to west at 60. So that's what my 60 will be. What is its resultant velocity? That's what my resultant will be. So what is its resultant velocity? Now, we have the magnitude and direction given. So my theta is going to be here. So now, here's north, here's east, and here's west. So based on the diagram, I can eliminate the wrong answer even before I start solving. Because I know that my answer is going to be between north and west. So if you look at the option A is going to be wrong. Because option A, the answer is between north and east. So that will not correspond with our final answer. And option B is also going to be wrong. Because the answer is between north and east. So what I will need to wait for is option C and D to get to know which one is the correct answer. So now let's get the resultant first. For the resultant, r square equal to 60 square plus 100 was square. So get r square as, so I'll give us 3600 plus 10,000. So now I'll get r rather. So I'll get r equal to, the out of this you get 13,600. So r will now be square root of 13,600. That will give approximately 117 watt kilometer per hour. 117 watt kilometer per hour. Now, since I've obtained the value of r, automatically I'll know that the answer is going to be option what C, because this one is giving what 1117. But just for clarity, let's get what the value of what theta. The direction tan theta is Fy over what Fx. So I get tan theta, Fy, the vertical component is 100, Fx, the horizontal component is what 60. So I'll get tan theta equal to, we have 100 divided by 60. That will give us 1.6667. Theta becomes the tan inverse of 1.6667. We'll find the tan inverse of that. So that will give 50 watt 9. So that will give what 50 watt 9. Then now, if you look at the option here, you see that there's no 59 at this point. So now let's see how we get what the correct what answer. If you have followed our series from part 1, this one will not be difficult for you. I've taught you all the different ways of getting what the direction. So now, I know that this is where the angle is going to be. So we have this, which is the north. I have this one, which is what the west. And here's the theta. Here's the theta, which is for 59 here. And of course, the other angle here, that's going to be what 31 what degrees. Because 31 plus 59 will give us what 90 what degrees. So now if you want to take your reading now for the value of what theta, what I will get is, for this particular one here, you can write the answer as r equal to 117 kilometer. With respect to the 59 is closer to the west. So I'll read that west, 59 degrees what north, which you can also write as 117 kilometer, 59 degrees west, okay, sorry, north of west, which means the angle is closer toward the west. But with respect to the option we have here, you can have arrow as 117 kilometer. Then with respect to this part now, this angle is closer to the north, so I'll have north 31 degree west. And that is what we have here. And then another way you can write this answer, you can also write it as r equal to 117 kilometer, 31 degree west of north. So the other equivalence, but this one is what you have in the option. That's why I said it's necessary for you to know how to get all the equivalent way of writing what the value for what the direction for any given what vector. But once you understand that, it becomes easy for you to get what the direction. So it's not something difficult. So let's take a look at the next example. Let's see the next example. Now for this next example, after writing the question, just pause the video and see if you can actually solve the question on your own It says a man walks 2 kilometers east. A man walks 2 kilometers east, then 6 kilometers, 30 degrees east, (6 kilometers, 30 degrees east of north). East of north. Then 5 kilometers, 60 degrees west of north. (5 kilometers, 60 degrees west of north), and then and then 2 kilometers south. Full stop. What is its displacement from its starting what point? What is its displacement from its starting what point? Now, if you want to obtain its displacement from its starting what point, let's see how we draw the diagram first. The man walks 2 kilometers east, that's this way, 2 kilometers. Let's place that first. Then 6 kilometers. The 6 kilometers is between east and north. So this is north, here is east, here is south, here is what? West. So between east and north, I'll have this one here, 6 kilometers. 6 kilometers between east and north. So 30 degrees east of north. 30 degrees east of north means the angle is closer to what? The north. So I have 30 degrees there. Then 5 kilometers between west and north. West and north. So we have that 5 kilometers. But now it says 60 degree, which is closer to what? The north. So I have 60 degrees here, closer to the north. And then 2 kilometers south. And then 2 kilometers south. So we have the first 2 kilometers, which is that. 6 kilometers, which is that one. Then we have another 5 kilometers here for this one. Then we have the last one, 2 kilometers south, which is this. So now that's the diagram. Now that you have drawn the diagram, it becomes what easy for you to actually solve that question. It's not something really difficult. So now let's find the horizontal component. That's resolution of vectors. Horizontal component. Let's resolve to the horizontal direction. Fx. Now this part is positive. This part down is negative. Here is negative. The up part is what? Positive. So now for the horizontal direction now, for the horizontal, okay, first of all, you see that there's a 2 kilometer displacement along the horizontal. So that one is on the positive axis. So I have 2 here. And I'll move this one, this 60, to that direction where there is no angle. So I'll get 6 sine 30. Then this 5 kilometers, I also move it down, but the part I'm moving to is what? Minus. So I'll get what? Minus here. I'll get minus there. Then the part I'm moving to is not where I place the angle. So I'll get 5 sine 60. 5 sine what? 60. That is for the horizontal what component? So this will give us 2 plus 6 times 0.5, 5 times 0.866. So we have 2 plus 3 minus, let's multiply, 0.866 times 5, that'll give 4.33. So I'll get 5 minus 4.33. That'll give 0.67. That'll be 0.617. So the next thing is to get the vertical direction Fy. Now for the vertical direction, if I move the 6 kilometer force displacement this way, 6 kilometer displacement to the vertical direction, the path I'm moving to is positive, and that is where I have the angle 30, so I get 6 cos 30. Then the 5 kilometer are resolved to the vertical as well. The path I'm moving to is also positive, and that is where the angle is placed. So I have 5 cos what? 60. Then along the vertical direction, we have the 2 kilometer displacement towards the south, which is the north, the negative part. So I get minus what? 2. So now, so I'll give us 6 times 0.866 plus 5 times 0.5 minus what? 2. So multiply 0.866 times 6. That'll give us 5.196. Plus 2.5 minus what? 2. That'll give us 5.69 what? 6. That'll give 5.69 what? 6. So the next thing is to get what? The resultant. The next thing is to get the resultant. So the resultant, Fy is positive and Fx is what? Positive. Fy is positive, Fx is positive. So resultant will be Fs squared plus what? Fy was square. So we'll get resultant as 0.67 squared plus 5.696. So we get arrow as, let's get those values now. 5.696 square. That'll give 32.444. Let's say 32.44. Then 0.67 square. That'll be 0.4489. You add it to 32.444. So that'll give 32.8933. And then when you find the square root, that'll give us 5.7. 5.7 what? Kilometers. So now the next thing I will do is to get what? The direction. to get for the direction. So for the direction, we have tan theta. We have tan theta Fy over what Fx. Fy is 5.696. All of our Fx 0.67. So that will get tan theta. We divide that 0.696. Now 5.696. 5.696 divided by 0.67. That will give 8.5014. 8.5014. So that theta will now be tan inverse of 8.5014. That will give 83.3. 83.3 what degrees? degrees. So now Fx is positive. Fy is what? Positive. Fx positive. Fy positive. That's positive Fx and positive what? Fy. And here's your resultant. And here's your theta, which is 83.7. So 83.3. So this other angle alpha, that will be 90 minus 83.3. And that will give 6.7 what degrees. Okay, that's necessary because I'm going to give you the 4 different ways you can write this answer. So here is north, and here is what east. So now the resultant is 5.7. So R equals 5.7 kilometers. 5.7 kilometers. Then this first one is closer toward the east. So I have east 83.3 degrees north. Same thing as 5.7 kilometers. 83.3 degrees north of east. And then with respect to the vertical direction, we have 5.7 kilometers. 6.7 is closer to the north. So I have east of north. Can also write as 5.7 kilometers. North, 6.7 degrees what east. So that's the 4 different ways you can write that answer. And the 4 of them are equivalent. The 4 of them are equivalent. So let's see this relative velocity question here. Says 2 cars A and B are moving uniformly at 36 meters per second and 108 meters per second. Respectively. Full stop. Calculate their relative velocity if they move along the same line and the first one in the same direction and the second one in opposite direction. So since it's relative velocity, if they are moving in the same direction, what I'll just do is I'll have 1 weight minus what? 36. And that'll give us what? 72 meters per second. That's if they are moving in the same what direction. If they are moving in opposite direction, what you need to do is just addition. In opposite direction, I'll have 1 weight plus 36, and that'll give us what? 144 meter per watt second. 144 meter per watt second. So anytime you have relative velocity questions, once you are told they are in the same what direction, if they are moving in the same direction, just do a subtraction. If they are moving in opposite direction, we do what? A simple what? Addition. We do a simple what? Addition. Now let's see this other simple question here. This one is different from everything we have done in this series. So watch closely for this one. Determine the sum of the displacements A and B, whose components in meters along 3 perpendicular axes. We have AX 5.0, AY 0.0, AZ minus 2.0. And for the other one, we have BX minus 3.0, BY 4.0, Then BZ 6.0. Now for this one, it's a very simple question. You can do this one in less than a minute. And do this one in less than a minute. We find the S component now. We have 5 and minus 3. Add up that. 5 plus minus 3. So that will give us 2. We have the Y component, which is 0 plus 4. So that will give us 4. Then for the Z component, we have minus 2 plus 6. That will give us what? 4. So now the resultant, or the sum of the displacement. Now the sum of the displacement is the same thing as what the resultant. So we get S squared plus Y squared plus what Z was squared. So that will be 2 squared plus 4 squared plus 4 squared. This will give 4 plus 16 plus what? 16. So that will be 36. And square root of 36 will give us what? 6. We're told that the displacements are in what? Meters. So that will give us what? 6 what? Meters. So whenever you have a question like this, just add up the S components, then add up what the Y what components. And when you do that, you find what the resultant by using that simple what formula. Use that simple formula, you get what the resultant. There's a similar question to that. It says the dimension of a dining hall at 10 meter, 10 meter by 12 meter by 3 meters. Full stop. A flight starting from one end from one corner, pitched at the opposite corner. Full stop. Determine the magnitudes of its displacements. So this one is similar to the last question we did. So we have 10, 12, and what 3, which represent the X, Y, and what Z. So the magnitude of the displacement, that will be 10 square plus 12 square plus 3 what square. So we get 100 plus 144 plus what? 9. So add up that, and then find the square roots. Now the square root of 2, 5, or 3. And that will give 15.9. 15.9 watt meters. So, whenever you have questions under vectors, it's very easy for you to solve. Just understand the simple principle we'll be looking at under resolution of vectors. And if you've not watched the part 1, 2, and 3 of our previous word series under vectors, mastering vector calculations in physics, part 1 to 3, try and look up that. There are some questions I did in part 2 and part 3, which I didn't do anything related to that in this part 4. Ensure you look at that. If you have any question on that, send it to me through the comment section, and I'll